The Internet of Things. So when we're talking about big data and data being generated by the transactions, we take the cameras that are filming the streets, the emails we're sending, the forms we're filling out, the social media posts, and so on, that are being recorded and published. We are largely talking about online, but also offline systems, but largely kind of human generated. What adds really to the big data world that we're living in is also the fact that physical objects themselves are connected to the internet and generating data. And in some sense, kind of when we're thinking about cameras, they are sort of sensors in the environment that collect data, but everything is becoming connected. The buildings are connected, the house is connected, the train, the bicycle, the road, the cars, the coffee shops, the appliances, the refrigerator, the stove, the thermostat, and so on and so on. So we're really coming into this world of the Internet of Things, what that is when things are themselves connected to the internet. So the Internet of Things is the term that refers to the connection of physical objects to the internet, cars, fridges, pacemakers, even items we install inside of our body, bridges, buildings, thermostats, and so on. It has developed in part due to ubiquitous computing, ubiquitous wireless internet access, commodity sensors, that is cheap sensors that are available and that are easy to implement to obtain, to be connected to the internet, and also the machine learning algorithms, which we'll talk more about later. Here I will continue exploring a little bit of characteristics of the Internet of Things and some challenges and technologies associated with it. Here's a framework of the IoT, not of the IoT architecture, it's just a generic framework of IoT architecture. And we can conceive of the Internet of Things of referring to three types of layers. So there's the perception layer, and this is kind of this area over here. So these are the actual physical objects that kind of perceive or sense the data. So this can be temperature, pressure, humidity, motion, light, or other types of sensoring devices. Wearable devices, sometimes even phones or other items people wear or put on themselves are this perception layer. There's also a network layer, which is related to the transmission of data. We talked a little bit about protocols when we're talking about the web and the HTTP protocol. Well, different devices may need a different kind of protocol for transmitting the information to facilitate and make it more efficient, the transmission of data. So that's another sort of layer of the IoT, of a generic IoT architecture. And then there's also the application layer, which is about the processing and the presentation of data. And this will happen kind of more on the cloud, but also on the mobile devices or the desktop devices or other server computers that process and display and manage that data. IoT applications. So there are all kinds of IoT applications. And in the consumer area, we have these so-called smart homes, so homes that can respond to changes in the environment. So a thermostat that will go up and on depending on the temperature, things like that. Wearable technologies that can track our behavior or respond to how we're doing. Connected cars, asset tracking, patient monitoring, agricultural automation. There are applications in the educational sector, such as attendance monitoring. So the idea is you may have just cameras, and the cameras can count the students without anybody needing to count them. Safety features potentially, maybe cameras or other kinds of sensors can detect either objects that should not be in the school and then alert someone automatically, things like that. Industrial application in management, in production, monitoring, in quality control, in safety and security. These are just some of the examples that are already being used, but also that could be developed in the Internet of Things. There are, of course, some challenges. There's security challenges. Who can access this data? The data is everywhere. It's floating everywhere. Are there reliable systems of protection for the data? Do people correctly classify what is sensitive data, what is not sensitive data, and so on? Where is the data stored? What are the costs associated with storage? Connectivity, how reliable are the connections? If you depend on a system that depends on the internet, if you lose the internet, you lose your system. So how are we approaching the reliability of connectivity? Also social impacts. So what are the opportunity costs when we focus on just building internet or connecting items to the internet? What other kind of issues are we not addressing? What are the impacts of these connecting devices on our health, on our mental health, on our quality of life, on the amount of work we have to do, and so on? So there are various challenges there. Here is a diagram that actually integrates some concepts of big data and analytics solution for Internet of Things. And I'm getting this from this writing here that I will also share with you. And we already explored some of these concepts in some of the previous lectures. So the big data challenges, or more like big data characteristics. I will also be talking about kind of big data patterns, or the types of data that we deal with when we're talking about big data nowadays. Well, maybe we'll talk a little bit about big data sources, although we did already talk about the kind of sensors and where information may come from and the applications they have. There are also big data system components, and I will integrate that, this idea of data acquisition, data retention, data processing, this sort of data life cycle. I will integrate and talk about that along with the analytics frameworks and tools in the next set of lectures, exploring these kind of dimensions here when we talk about data science. So we'll go to that next.